Chapter 2, Lesson 1, going to spend a short video looking at linear equations. You'll have some problems like this in your book. Match the equation for the linear function that satisfies the given conditions. So I have these linear equations over here that are actually in the form y equals mx plus b, because remember f of x simply means y. And we need to know which one of these equations matches these 2 points. Now, what we talked about in the last video, again, is simply a matter of notation. It's not a real change in anything. Remember, f of x actually means y, so this is the y value that you get. Where's the x value? Well, the x value is right in here, f of x, so this is the x value, negative 5. When we substitute that in, we get it negative 1. So this ordered pair is actually negative 5, negative 1, and then this ordered pair is the x value of 2 and the y value of 4. So really this is just functional notation for listing an ordered pair, negative 5, negative 1, and 2, 4. So that's really the only change. So then we just need to review and remember, how do we now write the equation of a line if we know the 2 points? And again, you're always going to start in point slope form, and because unless you know what the y-intercept is. If the y-intercept, if you know that, then you can simply calculate the slope using the 2 points and then substitute in the y-intercept. For any other point, you're going to have to do point slope first and then solve it for y, making it y-intercept. So let's do this first example, we'll do the first example. I'll go over here. So this is just functional notation for an ordered pair, so I can turn this into its ordered pair. So negative 5 is the value that's substituted into the equation, and when you do that you get negative 1, whatever that equation is. And then this, it was going to be an x value of 2 with a y value of 4. Now, I'm going to use point slope form first because neither one of these points is the y-intercept. The y-intercept has an x value of 0. Neither of these is 0, so I need to start in this form, and then I'll solve it for y to get the slope-intercept form. So I'm going to choose to do, well, I have to do the slope first. I almost forgot to do the slope. So I need to figure out the slope. So the slope is going to be negative 1 minus y2, or y2 minus y1. And then negative 5 minus 2, so that's negative 5 over negative 7. 2 negatives make a positive, so my slope is 5/7. So now I can choose either one of these 2 points substituted into this equation along with my slope and then solve it for y. Now I choose to use this one because I prefer to work with positives rather than negatives. So I'm going to go y minus the y coordinate of the point I've chosen equals the slope, which I calculated at 5/7, x minus, and then the x coordinate is 2. So then I'm going to distribute, because now I have to solve this for y in order to get the slope-intercept form. So this is 10 over 7, right? And then I'm going to add 4 to both sides. And now I need to add these 2 fractions together so they're simplified. And so, well, this isn't a fraction, but it's going to be because I need a denominator the same. So I'll multiply both of those by 7. So I've got negative 10 over 7 plus 28 over 7 then. And that's going to give me 18 over 7. So my form then is y equals 5 over 7x plus 18 over 7, and then if I use function notation, put it back in that. This function has a variable of x, so it's f of x is equal to 5/7 x plus 18 over 7. So if I go back here, that would be this one, so this is the match for that one. Okay, so let's go ahead and do this second one here. And again, if you think you got it, you could stop the video and move on, but I'll do another example in case you need one. So here we have the 2 points, and so again, I want to figure out what x is. That's the number f of x in here. This is the y value that's produced by that. And then this is the negative 1 with a 2. So again, I want to calculate my slope first, so it's y2 minus y1 over x2 minus x1. So that's going to be 4 over negative 3. So my slope is a negative 4/3. So then again, I'm going to go ahead and choose either one of these points to put into my point-slope formula. It doesn't really matter. One's positive, one's negative. So I'll choose this one because these numbers look smaller, so I'll use that one. So y minus the y-coordinate is equal to my slope times x minus the x-coordinate. I'm then going to need to distribute. And then I'm going to add 2 to both sides. And now this needs to be a fraction with a 3, so I'm going to have negative 4/3 plus 6/3. And so that's going to be 2/3. So this would be y minus, no, y is, well, let me back that up. Let me back that up a couple notches, and then let me move this up a little bit. It's a little bit easier to see. So I'm going to have then y is equal to negative 4/3 and then plus 4/3 x plus 2/3, and then I'll use the function notation. This is f of x. So negative 4/3 x plus 2/3. So if I go back here, negative 4/3 x plus 2/3. So this one goes with this one. Now I'm going to do this one real quick just so you can see that if you recognize the initial value or the y-intercept, you can go right into y equals mx plus b. This is the coordinate 0, 3, and this is the coordinate 3, 0. Alright, so all I need to do is figure out the slope. So if I do the slope, I've got 0 minus 3, 0 minus 3 over 3 minus 0. So that's going to be negative 3 over 3, which is negative 1. So my slope is negative 1, but I recognize this, the x value is 0, so this is my y-intercept. So I can go ahead and substitute this right into y equals mx plus b, giving me y equals negative 1 x, and then my y-intercept is 3, so this one goes with this equation here, which means this one would go here. Okay, so that's how you make those linear equations given the function notation of our coordinates of x and y.